is
I'm
coming.
starting it, Avinash.
Okay. Now we started.
Hey, hi all. Thanks for joining the Pune meetup. We are still waiting for the other attendees to join. So I can see 9 people have joined. So we are just waiting, maybe next 3 or 4 minutes, we'll give for others to join. Yeah, so we'll start shortly. Thank you. Hey, Anjali, can you confirm you can hear me fine, Kundan?
Yeah, it's nice. I can hear you properly.
Thank you, Anjali. So we have 15 attendees and we are just waiting, a few more minutes. We'll give them to join. So it's 3:01. So maybe like we'll give 2 to 3 minutes more. Hey Avinash, if you are still in the call, how do we allow everyone to talk? They will be muted all the time, right? Okay, I will check that. So everyone, we are still waiting, like maybe 2 or 3 minutes more. We'll start shortly.
Hello.
Hey, hi Kundan. Yeah, a little disturbance, but yeah, we can hear you.
And what about video? Video.
Yeah, video, we can't see you, Kundan. Okay, so it's already 3:04. I think people are still joining, but I don't want to lose the time, and we want to strict on the time. So I will get started. So just confirm, Anjali, you can see my screen, right? Fine.
Yeah, we are able to see.
Yeah. So thank you again, everyone, for joining. I know it's a Sunday afternoon. So thank you again for joining. And this is the Pune meetup. And you all know, like, there is a heavy rain in Pune from last 1 week or so, even in all the Maharashtra coastal area. So it's raining like cats and dogs here. So yeah, thank you again for joining. And today our topic is Async API and Dataweave library. So I've been joined along with Kundan and Anjali. So they will be talking in detail, and we are also going to discuss about the use cases, and with running demo also, we'll plan to show you within the time limit. And with that, I just want to show quickly these guidelines. I mean, this is we already seen so many times, but please keep yourself muted. And if you have any question, then please use the Q&A section to send the question in the chat session, and we will take those question in the question and answer section. We definitely want to have a discussion during the question and answer to make it more interactive. So we will do that. And please provide your valuable feedback at the end of the meetup. We would love to know what are your views, and what you think about the topic, and what else you want to see. Okay, so let me quickly show you. So I will be I am the organizer and also the speaker for the event. So just a brief intro about me. So I'm one of the MuleSoft architect at Sama, and I have around 15 plus year of experience, and integration and the middleware is my core skill. And as you know, like Sama is one of the company working with the leading pharma companies for custom based pharma solution. So I'm also a part of that. And along with me, we have two more speaker with me, Kundan and Anjali. So they are also from Sama, and Kundan is senior tech lead and Anjali is a MuleSoft developer. So they will be giving the intro once they will start their discussion. And before we start, would just like to give some updates about the recent happening with the MuleSoft. So MuleSoft recently introduced 3 new products, as you already aware: the Anypoint Flex Gateway, RPA, and the API governance. So as you know, API governance will help you to force the standard and the quality with all the API. You can see what are the checks and the standard being followed across the API or not. RPA is the recent launch in MuleSoft Connect. So RPA will help you to create the bots for the repetitive work. For example, if you want to get some data from a scanned document, so those kind of job RPA can do. So I mean, this is not a topic, but this is also a very interesting launch for the MuleSoft. And then the Flex Gateway, which is even used to manage the non-MuleSoft API. So this is a single platform where you can manage all the different gateways. And of course, I have given the MuleSoft release notes and the RPA link. You can go there and get more details about this recently launched product. And of course, we have MuleSoft resources. We have blogs where you can find the recent product updates and the recent events happening in the MuleSoft, along with the technical topics also. We have forum where you can ask your question, all the technical question related with the MuleSoft. And the training site is used to get the training and the certification on the MuleSoft. And of course, I've given the link for the MuleSoft Connect, which recently happened a few weeks back. And a lot of new updates and event happened. So you can get all the recordings at that site, which is given below. So with that, without wasting any further time, we will, start with the agenda, what we are going to discuss. And please, guys, you can always use the Q&A and chat window to post your question. We will take that. And these are the topics we are going to discuss. As I told you, we are going to discuss the Async API, and Async API is nothing but a part of the event-driven architecture. So we'll be discussing that. And we will also show you a use case for the HR application where the Async API will be used. And of course, Anjali will be giving a demo of the Dataweave library where she will be discussing about the use case and the demo and how Dataweave library can be used as a reusable component. So I think Kundan, you can take over with this slide, and everyone, you can always post your question, okay, in Q&A. Yeah, over to you, Kundan.
Thank you. Thank you for this introduction. So, hi, hello everyone. I'm Kundan Kumar. I'm working in Sama as a technical lead, and I will be discussing about event-driven architecture. So, for that, I'll be so I'm requesting you to stop so that I can start sharing screen.
Go ahead, Kundan, please.
So let me know when you can see my screen. Yeah. So I hope my screen is visible.
Yes, you're visible. Your screen is visible. Mhm.
Yeah, thank you, Anjali. Yeah. So, so before we start, actually, to understand what is event-driven architecture, let's first try to understand the types of communication that happens between APIs. So, there's two types of communication. What generally happens between APIs, like it is synchronous call or communication, or it is asynchronous communication. So in case of synchronous API communication, the caller API calls the server API and then waits for the response from server API. Whereas in asynchronous communication type, the caller API calls the server API and do not wait for the response. So basically, these are the two kinds of communication which happens uh, between APIs. So in synchronous API structure, so the request, uh, when the API makes a request, that request goes to the server API, and then server API in turn calls multiple APIs to perform that service, and then gives the response to the caller API. Okay, so mostly the the challenges what we face with the synchronous APIs are communication are like, whenever a request enters, it has to it has to, stop in each and every node and wait for the response from the server API. By this, uh, in this type of communication, generally what happens like, it makes the whole architecture tightly coupled service architecture, right? Where all these services are tightly coupled with each other and wait for the response, so making it less flexible. And by flexible I'm like, in this structure, if we try to include another service, that may require some kind of changes in this current structure, so making it more rigid kind of model. And even the failure cascading happens like, if one server API get failure, that failure is cascaded to the caller API, and then the that particular error will again be passed on to the his caller API. So the failure cascading happens. So and even because of this request waiting on each and every node and waiting for a response, the response time increases, which actually slows the customer performance, right? Because customer has to wait for the response. And also we have seen that in this kind of synchronous, like when we are creating a API which is going and at a given point of interval goes and pulls the data on a server, right? So most of the time, the new information which it receives is very less. 98% times there is no new information coming in to get processed. So these are the basic problems with this synchronous communication. So then when we see async communication, that basically says like, we do not need to wait for a response from the server. We just need to take the request, pass it on, and then forget. So general terminology we say fire and forget. So in these scenarios where we do not need response from server, we can go for async structure, async communication type, such as like the scenarios where a new user signed up, new follower came, or there is any fraud detection services running. So these services run and do not need any um, response from the server actually. So this is s- and then event driven architecture generally uh, works on this async model, where APIs communicates asynchronously based on an event. So whenever an event occurs, the flow get triggers without anyone specifically requesting for that particular service. Based on an event, the service get triggers. So the concept is very simple, like there will be a one publisher, there will be a message broker, and there will be a subscriber. So publisher will publish the message on message broker, and all the subscribed APIs will get triggered once the message is published on the message broker. And publishing of message to a message broker is considered as an event. So that is the reason whenever a message arrives to the message broker, it is considered as an event, and all the other APIs subscribed to that particular channel gets triggered, and no one has to actually go and trigger it. It triggers on the basis of event. So in we have multiple message brokers which we can use like Kafka, RabbitMQ, ActiveMQ. So we can use these message broker to actually facilitates this communication. So here we have a use case, which is event-driven architecture use case, and see in the traditional model of API creation, we have we all know that we follow three-layered architecture where we have experience API, process API, and system API, and we design the APIs which lies in either of these layers. So in this example, we are trying to include event-driven architecture with our traditional three-layer approach what we have. So in this example, you can see in Experience API, we have one API called Mobile API. In process layer, we have event handler, order status, customer, and then in System API, we have sales, SAP, and orders. So this is the traditional way of creating a API-led connectivity concept, right? Now we have added active MQ in process API layer. So this is nothing but a message broker, which is having one channel named order. So now what will happen whenever a user wants to cancel an order? So this use case is for canceling an order. So whenever the user will make a request to cancel any particular order, the mobile API will validate the customer and will then publish the message to this order channel, right? And now from this order channel, the event handler API will be subscribed to this particular order channel, and it will get invoked and it will consume the message. Once the message is published to the order channel, it will be picked by uh, event handler API, and then event handler will check the message what it has received, and based on the message, it will route it to order status or customer, right? So in our case, since it is a cancel of order, it will the message handler will read the event handler will consume the message and then will invoke the order status API, which in turn will call order system API, and then the details will be updated to the user's cart. Okay, so by just introducing this EDA model in our existing traditional API-led connectivity model, we are actually achieving like we are making this whole structure as a event driven architect, right? Event driven model. So where we actually uh, makes a benefit of event driven when event driven architecture, right? We so here what is happening, like whenever a request comes in, it does not has to wait on each and every node. It will be just published to the order channel, and from order channel, based on the processing capacity, it will be picked and will get processed, right?
So Kundan, sorry to pause you. So one point I would like to add here. So if you see the traditional API-led approach, what we have, right, where we go top to bottom, we start with the experience API and lands at the system API. But here, because we have added the async API in the process API or the async API model, now let's suppose we have a big a shopping cart company, something like a Walmart or maybe something like a Amazon or Flipkart, right? They need to take hundreds of orders. Maybe out of those 100, maybe 40 or 50 will be cancelled, right? So here we are showing you a cancel order flow. Now, in this flow, if you use a synchronous event, something like what you do with the traditional API, you will engage the complete flow, okay, till the time the order will be cancelled. But here what happens, we take the request, we put it in the channel, and then we forget. So after that, one by one the order will be taken and will be cancelled. So at the same time we can take bulk request and we can process them. So this is the power behind the combination of async API along with the traditional API led approach. Yeah, Kundan, go ahead.
Yeah. So yeah, by making this, the processing gets APIs do not actually hold the processing capacity. Yep. And also by making this adopting this approach, we make our system more scalable. Like let's suppose a new API or new functionality or new service needs to be added, we don't have to make any change to the existing one. We can directly include it, and the message event handler will pass the message to that particular system, particular service based on the message which is arriving. And another point is like here we have introduced this async API, and we have used only one channel, and using this as single channel we are able to make the structure more reliable and cost effective. So yeah.
Yeah, if you see, yeah, sorry, Kundan, one more thing to add. If you see in the diagram, we have added order plus the customer. So the same queue is used for both order and the customer. And if you see, event handler is nothing but a kind of choice router, which is directing the request to the correct process API. So in case of customer request, which may come from the experience API, we will pass it to the correct channel. So with the one queue, we can handle multiple flows. Yeah,
Yeah,
Kundan.
thank you. So let's first see. So even this event driven architecture is nothing new. Actually, it has been there for decades, and this promising the to deliver powerful and loosely coupled high adaptive and responsive experiences. But still it has not been widely accepted because of few challenges we see. Like let's suppose we have an API where we have used async API, and we are connecting to some message broker and performing all the activities, right? But in the existing system we do not mention it in the raml, and that is the way, and that is the problem. Like even if uh, because of which we are not actually including this piece of code in the API lifecycle. Okay? And because of which this code is having less visibility and lacks industry standards, and even it is so people, because it is less visible, developers are not aware of it of 100%, and that is the reason this piece of code are not getting reused multiple times, because there is nothing, we are not specifying, we are not writing the details of these APIs anywhere. So these are the basic challenges because of which even even this event driven architecture being so powerful is not being widely used. So to overcome these challenges, MuleSoft has actually uh, now adopted this async API specification, where we can go and write the specification of the piece of API what we have created with all the details. So event-driven API is now supported in any point platform through Async API. So now in Designer, if we see, we have a new section which is like a Async API specification, and we can use that to document and and write the specification of the APIs what we have. So Async API is supported by following products in Anypoint. So currently only API Designer and Anypoint Exchange are the two products of Anypoint platform, which allows us to uh, give Async API specification as for now. So by using API Designer, we can design the API, we can write all the specifications over there, and then we can publish it to Anypoint Exchange, from where it can be shared with client, partners, or even developers. And developers can directly go and look into its specification, get out the details, and start working or start reusing it. So create, import async API specification in this API Designer. We can create or import the API specification in API Designer, and then edit and document and then publish it. Publication will be done through Exchange, and uh, then it can be shared with multiple, like with partners, clients, and developers. So they have all. So this API sync is a language that describes message interface and make it easy to work EDA by separating the API in three models. So basically, in a specification, while creating this specification, we have three major sections, like where which is called event, channel, and transport. So event is nothing but the message what exactly needs to be transferred is under event, and channel is like the destination of the message where it needs to be sent or received, and transport is the technology using which we need to send this message. So channel, we can think of topics on the message broker, and transport, we have multiple, like RabbitMQ is there, Kafka is there, ActiveMQ is there. We can use these transports to, whenever event happens, we can transfer the message on the channel using these transports. So by introducing this Async API in any point exchange, we have actually overcome these challenges, because of which the EDA architecture was not widely used, was not widely adopted. So like discover the reusable asset. So now we have this specification, and because of this specification, the piece of code is now more visible, and people understand it, and they can reuse it whenever applicable, and explore the and even by looking into that specification, they can quickly understand and explore the event driven structure, and understand what exactly is being handled over there, what kind of payload is being transferred, or message is being transferred on what channels. All details will be there. So by making this async API, this piece of async code is now documented, and now is a part of our API lifecycle. So it is much more visible, and because of this, even we can maintain standards, governance can be maintained over it. So there are some key takeaways from this uh, slides, like we can use async API as a specification to document the event-driven system to maintain consistency, efficiency, and governance. So consistency and efficiency and governance, because everything is now out, and now developer can go look into the specification, look into the environments in which we have message broker, and then they can easily use it, onboard it into their new API creation, right? So this makes the life of developer much easier. So there are multiple use cases where event-driven architecture is being used, EDA is being used. So this event notification or log aggregator. So here we use it for logging purpose. So let's suppose we have a services there of an organization where services are created in multiple to technologies, and APIs are created with using multiple tools and technologies, and we have we have to maintain log at the same place. So we can use this message broker, and all other services can directly connect to this message broker, and can publish their log details over there, and the organization can simply look into that particular message on that of the channels available out there, and can get the logs of each and every services running in their organization. Then this website tracking is also a very good use case for EDA model, where we can track the activities of the users on our website. So in these scenarios, actually no one needs to go and run the job. It should be on event. Someone logged in, someone checked the website, and those details will be published in the queue, or published in the topic, and that can be consumed and used, right? So we can maintain the track of the website also. Streaming processing so Netflix is using Kafka for stream processing, where mm, uh, huge payloads are to the queue, and multiple other users subscribes to that particular queue to uh, get the payload at the same point of time, with the same speed and with same uh, facilities, right? So it is being used in that case also. And message reliability is another benefit what we get. Like let's suppose we have a API, and then we have another API, two APIs are communicating, and let's suppose the server API is down. So if we have a message broker in between where the caller will publish the message to the queue or topic, and the downstream APIs will be taking the message from that particular message broker, it becomes very easy. Even if the downstream is not working or is having a down period, the message are not lost. Message still remains in the queue or in the topic, and even the caller API do not have any impact on this. They can just simply publish the message and then forget. Whenever the downstream APIs are up, they can go and read the message and consume the message and can perform the services. So message reliability is another benefit what we get from ETA. This AI voice assistant like Alexa. So here also event driven architecture plays the role, where we can give a command to Alexa for an event, and when that event occurs, Alexa will perform the service. So let's suppose example is like when we are leaving the house, please switch off the lights. So whenever this event happens, like whenever we leave the house, the Alexa will run the command and will switch off the light. The service will get uh, invoked because that event has occurred. Okay, coming to this API sync specification. So here we have details like we can. So in first screen you can see component, message, then security schema, and in second we can see servers and channels.
So Kundan,
So components are the section where we can write the reusable components which can be used or referenced in the API sync specification. So here we have a component, inside we have a message, and inside message we are defining the properties of that message. So a user signed is the message, and it is of object type, and then we can describe the properties of this particular payload. It has we can define the display name, description, types, all those things we can define over here. Then we have a security schema where we can mention the kind of security we have on our message broker. So
so
under this
Kundan,
server section, we can mention the environments what we have. Let's suppose we have a server for Kafka for production and for development. So we can specify under servers, we can write production, we can give the URL, we can give the protocols, we can give the description, and even we can mention the kind of security is on in this particular environment. And then we have channels where we define uh, what channels are available on my message broker, and all the services are either subscribes to it or it publishes the message to this particular channel. So we can go through it in a deep, we can look into it each and every um, attributes or every section. For that, I'll just go to my login. So in Design Center, we API is available in Design Center and Exchange for now. So in Design Center, if you see, if we click on Create New, here we have this new Async API. In this new Async API, we can create a new specification for Async APIs. So I have it here, greeting service. Yeah. So this is the specification. Is it visible or should I?
Yeah, if you can make it a little bigger.
So Ravi, this is visible.
Can you make it bigger, Kundan?
Hello.
Yeah, Kundan, make it a little bigger.
Hello, Kundan,
Yeah,
can
Kundan,
you hear?
Kundan, you can hear us? I'm not sure. He may not be able to hear us.
I think there is some network issue I'm facing.
Yeah, we can hear you, Kundan.
Okay.
Ravi, maybe you can message
Okay.
him.
Yeah, sure. Yeah. Kundan, you can hear us? Anjali, you can hear me?
Yeah, I can hear you. I guess
Yeah.
he is not able
Hello.
to.
Yeah, Kundan, we can hear you.
Hello.
Yeah, Kundan, we can hear you.
Yeah. Sorry, I kind of issues. Okay.
Yeah, go ahead. We can see that your screen.
Okay. So here we have um, on this design center, we can choose for Async API, and then we can start putting in the details of the APIs what we created. So currently we have Async API that version is 2.0, and then inside that we can give the information of the service what we have, like we can give the title, we can also mention the version and the description of what the service is doing. We have another section called license where tag, we can have this license tag and we can give the name of the message broker what we are using, and we can give the URL to it. So this section generally talks uh, about our API, like what information of our API is there. We can specify the title and all those things. The second section comes like it is a server where we can use this to specify the details of our server, the server of our the servers what we have for the message broker. So here, let's suppose we are having two servers. One is for development and another one is for production. So here we can mention the URL of the production Kafka, and then we can also specify the kind of prototype, and then we can give the description of the uh, this environment, that this is a production environment, Kafka broker URL and all those things. Similarly, similar goes for development environment, and if we have more environment we can add it over here. Then coming to this third section, which is channel. Here exactly we define what topic do we have created in Kafka. So we can mention that there is one new hire topic which is available, and this particular service subscribes to that particular channel, which is new hire. And then we can write the message regarding the channel. So here uh, we haven't actually written down here. Instead that we make the use of component section, where we can write the details and then can refer it in our anywhere in our code. So I'm using that. I'm referring to components message welcome node. So under component we have message, and then message name is welcome node, and then we can give the details about the message, like what is the name of the message, what is the title, summary, and what kind of payload it holds, right? And then under payload we can define the properties of the payload, actual payload. So here we made the use of schema, which is in component. So in component we can have message schema and security schema. So in payload we are using the schema section, where we are defining the actual payload, and what are the type of what is the type of this particular payload, and what are the properties, like it holds first name, last name, email, base location, and address. So this is a very basic one, which is for subscribing a particular channel. Okay. So this is the actual demo what we have prepared, where we are trying to include event-driven uh, concept along with our three-layer three-layer architecture, or three-layer API approach what we have. So in this demo, we are trying to show the HR application, where whenever a new employee gets onboarded in a company, their data is being entered on HRMS system, and then HRMS system invokes a service to create account, and then that after creating that account, multiple other services gets created. These services are those services which generally common for each and every person who gets onboarded. For example, greeting service. So whenever any new employee joins our organization, we drop a mail, greeting mail to them, a welcome mail to them, and there is some default trainings which they need to do, and there has to be some facilities granted to them. So these services we can consider this as a separate team handling these services, and we are just trying to show that even by just creating the entry in HRMS system, how the whole process will get triggered without anyone actually requesting it, but as the event has occurred, these all services ran. For that, let me see, I started my code. Yeah, it is running. So we are using Kafka in our example over here, and then we can take this as a home page, where onboarding form, where we need to fill the details, and then the details will be uh, and once we submit, the event will occur. So once we submit, the account service will be triggered, and then the user's account will be created, and all other services will get invoked because the account got created. So before that, we can also go and see the YAML. So this is my HRMS service. where we have this ramble. This is a very basic service where it will get a response and it will send a successful message by creating a account for that particular employee, new hire. Then greeting service we have just saw. Then we have account service over here. So we can go to Exchange. So in this account service, we have this channel, and this account service is publishing the message. It is publishing the first name, last name, email, base address, and address, publishing to Kafka new hire channel, what we have created. So the request will land over here. The process will start, and it will process, or it will create the account, and then it will publish the message to Kafka queue. After that, it will end, and all the other flows like welcome flow, training flow, facilities flow, we can consider it as a service which is looking up or subscribed to the same channel on which the message is being published, and this all will get triggered without actually triggering it, because the event has occurred. This all flow will start uh, execution and will perform the service, will give the service. So let me go ahead and fill in some details. So we have provided the details of 2 employees, and then we can submit it. And it gives us the message that the message is successfully created, the account is successfully created, and the message is successfully sent to Kafka. And then we can go ahead and check the emails. So for now, I have given my email because I need to see, I need to show you how what kind of messages we are getting. So once the account is created, the welcome email is sent out, the facilities mail is sent out, and the training assigned mail is sent out, and we can have the process inside. Like automatically, once the account is created, we received these mails stating that this process executed. So here we are just sending a welcome email for Kundan, and the same welcome email for Praveen. Then we have facilities email, which says that you have been granted a temporary access for Pune premises for 7 days, and the same facilities for Praveen in Chennai premises for 7 days. And then the training is assigned to is asking for a training login to training to portal, and to the trainings which is assigned under to-do list. So by this way, we can say that based on an event, which is account creation, all other flows started started execution without actually calling that service. So currently, the main limitation with this Async API is like we cannot import it into any point studio, because this is currently being used by a design API designer and any point exchange only. And then we can, so what happens, like whenever we create a ramble, we import it, we get a predefined code generated, API kit router generated. So those things currently we will not be able to handle. Maybe in future state it can happen. So Ravi will be discussing about the future state. So yeah,
Yes,
Ravi,
thanks,
handing
Kundan.
it to
Yeah. Yeah, let me take that. Let me share my screen.
yeah, sure.
So you can see my screen, right? So one of the participant asked, like, what is the difference between traditional API-led specification and the async specification? So this is the limitation what we have currently, and MuleSoft is already working on this. And we are going to see a full life cycle for the async API, which is not available presently. So right now, the problem with the async API is once you create the API specification in the design center, then publish it to Exchange, you cannot import it in the Anypoint Studio. So the only part what you can do is the design and publish in the Exchange. So MuleSoft is working on that, and maybe in the future we'll see this feature soon. And the second limitation is you cannot manage this API. So if you go to manage API section in the traditional API, you can apply all the policy, can see the analytics of those API, but that is not possible with the async API currently. So to overcome these limitation, MuleSoft is working on the future state. So I'm just want to show you the future, what is going to happen with the async API. So currently on the left-hand side, this document and discover part is already available with the Anypoint platform. You can do that just like what Kundan showed already. Like you can create a async API in Exchange Design Center and then publish it, but you cannot bring it into the Anypoint Studio and can play around with that. You still have to manage it separately. And the third part is how you can apply the policy and how you can do the analytics on that async API. So that part is going to come very soon. So this is one of the screenshot taken from the MuleSoft event sometime back. So this is not available currently. So what you can see here is this is the order async API, which we have shown earlier. And what happens is once you publish it to the Exchange, it will be available as a connector, which you can bring it on your Anypoint Studio, and you can directly use it within your application. So as you can see, once you can publish the async API, not only you can create a full life cycle, you can use it directly in the Anypoint. So it will become a reusable asset. So that part is currently being worked upon, and we will see this feature soon. So someone asked, like, what is the difference between the traditional API and the async API? So this is one of the difference, that we cannot use it directly. We are just managing the basic life cycle in the Anypoint Exchange. So this feature will come soon. And the second feature I talked to you about, the applying policy or to manage the API. So as you can see on the left hand side, there could be various policy you want to apply with the channel. For example, you want to put the OAuth, or you want to validate the schema. So those things are not available presently, but that will come soon to Anypoint platform, where you can manage it just like you are managing your traditional API. And the last part is the analytics. So analytics is also not currently available. You cannot see how many messages have been posted, or how your queue is behaving, and how your REST APIs and payload, what kind of payload is coming in the queues. So those feature also will be added along with the analytics, which is already available in the monitoring section. So that will also added to the async API. So as you can see, like async API is still not fully completed. It's still evolving. But very soon, what we are going to see is the full life cycle on Anypoint platform, whereas you can, mix your traditional API with the EDA or the async API and make it more real time, make it more like an event based instead of following the top-down approach. And this is, as Kundan showed earlier, a lot of use cases. So those use cases now can be easily achieved with MuleSoft. So that is going to come soon. Okay. So I think that conclude the async API part. And now I request Anjali to quickly go through the Dataweave library part, where she will be showing you the quick overview of Dataweave library, what it is, and how we can create a reusable asset in Exchange using the Dataweave. So this is also a new feature recently launched. Yeah, over to you, Anjali. So I will unshare my screen. You can share. Yeah.
Yeah, thanks. So just for, is my screen visible?
Yeah, you are good, Anjali.
So basically, like as we are able to just grab this. So first of all, I'll just introduce myself. My name is Anjali Devre, and I'm working in Sama as an MuleSoft architect. And I worked there from since 6 months. And I just want to let y'all know about the latest feature what MuleSoft is providing us, and that is what a Dataweave library. So what Dataweave library is exactly? So Dataweave library is something, an extension to what we were using a Dataweave for logical building blocks. So basically what Dataweave library is providing us is a reusable extension for a Dataweave logics, whatever we were writing till now. So what we used to do before, like when Dataweaves were there, we used to go and write each and every single logics, whatever as per the requirement or the needs as the conditions or situations we were getting into. So based on that, the Dataweaves were written. So what if the feature what we are getting nowadays is in the library format is that whatever the continuous or repetitive logics what we are using nowadays can be built in a library format, and we can use that by importing that into our codes. So we'll just go and let's just check it out that how it works practically. So as it's shows that it is a reusable extension of Dataweave logics. So how it is a reusable extension, I'll just show you practically. And it is how we can achieve those Dataweave libraries from whatever the logics we are building in the libraries, we are placing those in the anypoint exchange. And from that, we can definitely import that into our projects. So it is, again, I'll say a full life cycle. What I can say is it is an SDLC kind of process where we can design, test, and troubleshoot whatever the things we are building in the Dataweave library. So first of all, I know you all may be interested to know that what are the use cases the Dataweave libraries giving us, or what are the use cases where we can use Dataweave libraries are. So in the standard logging, what the standard loggings or encryption, decryptions or added logs are here, I'll just explain you in more detail. So what if we nowadays in our day-to-day lives, everyone use credit cards or debit cards. So using credit cards or debit cards, what happens? We have the data, a secure data with the banking or in the transaction, whatever we do, we have those data being secured by the banks, isn't it? So what happens? The data which we are going to provide for any kind of billings, or I'll say any kind of transactions, those data is what we need to encrypt and decrypt in our building structures or designing point of view. Like what happened in those scenario is, we most of the time, for example, we can take a billing example. In that, like if you are billing some of the our daily needs, or like say our electricity bills we are billing. So what happens in this scenario is, every time when we are going for a billing structure, we need some internal details to be given on the portals. So those details can be your card number, your credentials, kind of like your PIN, and the rest is like sometimes if you are it requires a CV number. So these things are something very important and very personal to be kept secured with. So what we can do is, these things need a specific payload which we can encrypt, and if a specific card is having these things, every time the structure will be same to like for the card basis, based on the cards. Like whenever we are going to bill by using cards, definitely the process will be same at the backend. So what happens, the process which is going to be same in the backend is going to go with a specific standard payloads. So those payloads are need to be encrypted. So what if we encrypt that in an exchange, keep it encrypted, like the logic for encryption to be kept in exchange in Dataweave library, and use that multiple times whenever a new organization come with their new bank or new card structure or billing structures using credit cards or debit cards, whatever. So this is the basic, and this is the daily use case I'm telling you, where we are going in our daily needs. So it will be easy y'all to understand how the Dataweave library is going to help us. So going further, I'll just not waste your time. I'll just let you all know how we can build it, how we can design it, and we can debug it and import it into our Mule projects. So I'll just show you a live demo. I have already built an API. So further, I'll just show you that how we can go ahead and create a project in Visual Studio. So first of all, I'll just let you all know that what are the prerequisites we need to go on with Dataweave libraries. So in Dataweave libraries, we need Mavens, we need Jenkins Mavens, and apart from that, we need Visual Studio and add-on Dataweave extension. So add-on Dataweave extension, we can get it from this Visual Studio itself. Going into then extension tab, searching just a Dataweave. We can see here. So here I am already using it. So it is installed on my side. For y'all, you can just click it here and install it. Rest, we'll see how we can create a project using this Dataweave 2.0 beta extension. So here we can go in a view palette. In command palette, just clicking here, we can click here Dataweave, and we can see create new library project. Just going there. What we need, we get some pop-up windows where we need to fill some of the informations. So I'll go ahead with build, just giving them. This is my organization ID, which I am going to use.
Anjali, we just want to keep a check on the time.
Yes.
Okay.
Yeah. So this is how I'll just go ahead. Just a minute. An example I can give any. I can say demo. This is the version. We can keep it the same, or if you want something, you can go ahead with. This is the project name. I can say conversion of currency. Okay, this is the place where I'm storing my project, and just will say that, okay, give me a new pop-up window. So this is how I'm building a new project. Y'all can see under this we have a conversion of currency project created, where we get this things. So under SRC main DW, we are getting one my module.dwl, and here is the place where we can write whatever the logic we want to implement. And in the test, we can in the mapping, we can just import that logic and just call that functions whatever are written in modules. So many of the time it happens that we need to keep the modules separated by a different name. You can just go to new file and just add with .dwl extension with whatever the things we need. Just because the time beings, I am not able to show you it more practically. I am already having one in my case ready. I'll just show you with the same. I'll just go on files, and you can see under DW I have created currency conversion.dwl. So here what I am doing is I'm writing the logic whatever I need to implement for. So what I am doing is I'm converting a dollar to rupees or euros to rupees. Then I'm just calling those functions in my function call just by importing those function name by the module which I am using. So further what needs to be done is in the POM file, we need to keep our in the M2 file, what we do is we keep our username and password being edited in this in that username password with any point exchange, whatever the credentials we are using to log in. So those things, from that I'll just show you all if you all want. I am having in this C we have users. Under users we are having .m2 file. Over here we are having settings, and in this what I am doing is I am just providing a credentials for my exchange, and in that we are getting this URL. If you all can see, this is the URL which we are getting, and I'll be using the same URL for further. So those URL we are going to make it updated in this existing POM file with under distribution management. Okay, under repositories we have distribution management. Under that I am just editing the URL with the one which we have in the M2 like M2 file, and again the ID also exchange server, it is same available over there. Okay, so I'm sorry. Now what we can do is once this POM file is updated, we can just go and check our exchange, any point exchange. So I have already logged into that. Going to exchange. Just we can see that the Dataweave library beta with a Dataweave currency conversion is created over here. Just going over there, we can see the documentation is also there. And apart from all this, we can just go to dependency snipper, copy this dependency, and I'll just show you in the current existing project. What we can do is we can create a project in the POM file. Again here under dependencies we can go and edit those. Okay, so under dependencies I have added those. Okay, any point exchange Maven support. Now what I'll do is I'll just execute this, and we can just see that how that will execute. So This is how the import I have done again in my data view. I'm just doing import the function which I want from that specific module and that module name. Okay. Whenever we can call that from Postman and we'll get $1 to rupees conversion in the Indian rupees. So anything else or any questions on this?
Yeah, thank you, Anjali. So we'll go to the question and answer section. So
Okay.
can I share my screen?
Yeah, I'll just stop from my end.
Okay, so we have already taken some time, so I just want to be on the clock. So, okay, so this is the question and answer section. So, we already have few questions in the chat section, so I will just read it out. So, yeah, let me start from the last question. So Pandya Rajan has asked, don't we have this Dataweave library creation feature in Anypoint Studio itself? Why we need external tool like Visual Studio? So currently to create Dataweave library, we have to go to Visual Studio and there is a plugin we need to install. And we have to create the reusable asset to publish it on Exchange. So this feature is not currently on the Anypoint. Anything you want to add, Anjali?
No, that is what MuleSoft may plan to go ahead with Exchange, but for now it is on Visual Studio only.
Okay, so Kundan, here is one question for you. The attendee had not provided the name. So is async communication and parallel processing communication same? If not, how async, sync and parallel processing is different?
Yeah. So async call and parallel processing both are not same. Async call is like where the caller caller API calls the service and then the service uh, and then not wait for the response from the service. Whereas parallel processing is something where we um, multiple services runs parallelly. So in event driven architecture, once the event happens, the process start based on that event, the process starts. But we are not having anything to the concept is not to run those services parallelly. The concept is to run that process when an event occurred. So I Ravi, I'm not able to see this question.
Yeah, it's in the Q&A section of the Zoom. Yeah, so there is one more question, Kundan, for you. In case if we have a template covering details related to EDA in a normal API specification, how is async API specification is different from normal API specification?
Okay, so in async API specification, we go ahead and write the details of the message broker what we are using. We write the details of the server. We write the details of uh, environments on which for which we have that message broker. Whereas in here also we have to define the channel where like publish or subscribe. Whereas in traditional we don't have publish or subscribe, right? We have a
Correct.
post, gate, put, these things we have. So in using this async API, we so in async API, when we go for the message broker, we can perform two activities only. Either we can publish the data or message on the queue on the topic, and from topic we can read it by using subscribe. So there is difference in RAML, but the concept is same. Even in RAML, we write the specification of the APIs what we are creating, and in async API, we are writing the specification of the async API what we have created, and that can be used and reused by other services also if they want to use it.
Correct. So just to add, Kundan, so that is why Anypoint started supporting async API, because the Kafka or any MQs we are using in our flow, there is no way to create that life cycle in the design center or in the exchange, because traditional API will only have the REST API RAML, right? It cannot have those channels, queues, publish, consume, those things. So that is why Async API is used for that purpose. So both are meaning the same thing. It's manage the life cycle of the API, but in a different way. The specification is little different. Just let me check if there is any more question. And I have also opened the chat section and the call section, so anyone can even unmute and ask the question. So any other question before we go to the quiz section? Okay, so if there are no questions, so we'll go to the trivia quiz. So this is the interesting part of the meetup. So we will be selecting 3 winners, 3 lucky winners, I will say, who will get the certification and the voucher of their choice. So that is given by the MuleSoft. So here is what we are going to do. I will just tell you the process. So I will be sharing a Google form link, okay, in the chat. And you guys will have 2 minutes, or I would say 2 or 3 minutes you can take, and you need to complete that quiz. It has the 5 question, and those who will answer at least 4 question, I will take them in the lucky draw, and we will be selecting 3 people in that draw, and we'll be giving those vouchers to them. So I already put the link in the chat section. Go ahead and open the link, complete the quiz, and I will be waiting for 2 minutes or maybe 3 minutes. And please provide your correct email address. That is very important. So that's how we'll be identifying the user. So please go through the question, select, and then do the submit. So maybe I will start a timer. So I'll just be unsharing my screen for a moment. Just one more minute and we will. Okay, so I have received 23 responses so far. Can everyone confirm if they have done that? Or we have 32 people. Yeah, can someone confirm if we can close it? Because I think it's already 3 minutes. So I think the time is enough, sufficient.
Yes.
Okay. Yeah, so we can go ahead and close it. So let me check how much I received. 26. Okay. So let me get all the email address. Okay. So what we can do is to just okay. Yeah, to make it little, little less in the. I'll be selecting at least who got 4 answer correct. So let's see how many people we have. Okay, so we have these many people. Okay, so I'll be taking at least who got 4 answer correct. And let's take them. And then we will be selecting 3 people out of them. Okay, so I'm just giving all the email and selecting 3 people from the list. Now let's see who are the winners. Okay, so we got 3 people. These are the email address. So guys, these are the lucky 3 winners. So can you please ping your name in the chat section? That will be great. I'm just putting all the 3 email IDs in the chat. So please go ahead and give me your name, at least the first name and the last name. And we will be sending the training vouchers to you. So yeah, congratulations to the winner. Let me go back to the slide. I just want to show one more thing, the references what I missed actually. So this asyncapi.com is the best place to read more about what is Async API, what it does, use cases. So please go ahead here. And there are some Async API documents you will also find in the Knowledge Hub. So please make use of that. And of course, in the document, the MuleSoft document will get the basic concept and the definition of the Async API. So that's it. What we have in this meetup. I hope you liked it. And the next meetup, we are also planning to have a physical event very soon for Pune people. So we are planning that. And I hope you have learned something new with this meetup. So please share your feedback, and we will be uploading this, use cases, codes, the PPT, and all the other details to the MuleSoft resources, so you can get that. And please do write back to me if you have any question, any feedback. That will be appreciated. So from me, Kundan and Anjali, thank you very much for joining the call. Thank you, guys. You have a good and wonderful day.